Hello folks, Reloading Bench back with you once again. And we got a package. Our Blue Santa stopped by earlier. And this is heavy. Allergies still bothering me. This is some metals. And it should be aluminum. As an old boss would say, aluminum. Not aluminum, aluminum. Or as a famous Apple designer, John Ivy, would say, aluminum. All right, enough of the aluminum. So now this is nice because if you remember, oh, that's thick. Oh, yeah, that might be too thick. Okay. So if you remember back in the day when I was doing my bottom of my Delta Unisaw, and I kept ordering whatever that plate was called, it was supposed to have this film on it to protect it. That I cared about, this I don't. So the reason for this particular plate, or these plates, one, because they were cheap on Amazon, and boy, that might be, yeah, that's, so my son is doing stuff to his vehicle, and he had ordered this particular piece that mounts in a display thing for additional enhancements, and this is steel, and because this mounts over an air conditioning port, thus the vents, he would prefer to do something in aluminum and then powder coat it black. Not this crinkle, but the powder coat that I'm capable of doing, which is just smooth black. So I took this, did some rough measurements to figure out what size aluminum I would need to buy, and thickness. This is 2.7 millimeter thick. This is 3, so just a tad bit thicker, which for, you know, all practical purposes is almost negligible. The concern I have, however, will be this bend. Don't know how I'm going to do that bend. Heat the aluminum up, put it in a vise, and then just bend it to 60 degrees. So in any case, I did a tracing of this, because what I will do is these two pieces, I will obviously transfer that tracing onto here, because that's what will cut out these pieces. But I'm also going to use the mill, because the mini mill, because I'm going to need to cut these holes, grooves, slots, whatever. But I've asked if it's okay if instead of these weird angles, and maybe this is too many, going after, he doesn't need this, he just needs a hole to pass a wire through. So I can get rid of, let me get my specific pointer out. I don't remember what I touched that looks like it's goobery, but let me put that off to the side and get a different one. Or I can get my official pointer. Let's go with the official pointer. Yeah. So he said for the original, he just needed a hole big enough to run a particular adapter and wire. I don't know if that's going to be big enough. We'll find out. So I don't need this particular cutout here. This is what actually mounts his display that actually goes on front here. And it has these for different displays, but he needs these two to be able to mount. So I will change that cut to this. This would be really simple with an end mill. Just drill, 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 and then end mill. Same thing here. Drill, drill bit, and then all of these. Again, I don't think I need that many, or he'll need that many. This is just conceptual, but from an exact tracing perspective, that's the exact size. and then change the angle. I don't need to match that angle, so I can just do a rectangular cut. So this will be the beginning of this project. I'll probably splice. That's the word I was looking for. Jesus, I'm getting old. Splice all of these together to make one video. But yeah, I don't know how I'm going to do this bend. I'm thinking heat and a vise. So, clamp this in, heat, clamp this much material in so that much is sticking out, heat it, and then I don't know if I'm going to hammer it. I don't know how I'm going to do that. So if anybody has any ideas, especially with 3mm thick, that's not a lot to do that bend. So I'm not quite sure. And I don't have a tool to do bendy, cool thingy stuff with. So I'm not sure how that's going to work, but that's the plan. So the plan is to take that and make it into this so that it's approximately this size. And then powder coat it black and then give it to him to do whatever he's going to do with it. So that's the plan. We'll see how that works. Definitely more to come later. Hello folks, Reloading Bench back with you once again for, I'm going to call this a mini update. The project of copying this, making these two pieces. These were all my measurements from the previous video, my exact tracing, so that I could, when the aluminum came in, there were 2 sheets of this aluminum. What is this, 4 inches or so? I want to say 4 by 12. 6 by 12. Yeah, it's amazing, men with rulers. Yeah. So I cut one piece so that I could actually make 2 of these. Well, I don't intend to make 2, but I anticipate foobarring that I might need the second. So technically I can make 4 of these things. So I can mess up 3 times. So I started, after cutting, I started to etch. I don't know if the camera's picking it up. I tried to etch the values here. And I don't know how good I got it. So we'll see. Like I said, this one's the trial. So I will clean these up. I'll probably cut that off and then put this in the mill and see if I can cut those holes. And I need to also make a circle here for the power. So I don't need this top. Again, don't know if you can see that. Just the 2 sides here. I don't need that, just the 2 sides and a circle there, and then this will be perforated holes, I think, for some type of design, but we'll see how it goes. So it's in play. No hurry, not in a rush to get it done, because I'd rather do it once and do it right than do it multiple times. More later. Hello folks, Reloading Bench back with you once again. In this segment, I will append to the previous videos around this thingamajiggy, that I'm trying to make. I'm trying to copy with my own flair. So I can't remember what I showed before, so I'd have to watch the older video. But I have the 2 main pieces. These 2 pieces. This piece unbent, and this piece. And as you can see, my design is, instead of doing these slats, is to do kind of a perforated hole approach, and instead of a diagonal rectangular thingy thing, I'm just doing a square. So this piece, the holes are 1/4 so these have been drilled out. 1364 I think was the correct bit before I tap it to 1/4. And I don't know if I'm tapping it to screw this way or to screw that way, because these are purposely not even. So I believe this is the long side. This looks, yeah, that looks about right, as opposed to if I put it on this side, you'll see that things are way off. So this is by design not symmetrical. It is a copy of this. So I'm sure somebody will say, dude, your holes are off. No, they are not. So again, I will tap it when I'm finished, or more finished. I drilled a hole in here because the idea, and the same thing here, only I didn't get as far because this wouldn't fit in my vise, because it was a longer piece that I have since trimmed a little bit to be closer to the actual size. So you can see, or maybe not, depending on how the camera's catching it, I've etched out these three. So I have the square and the two sides, and I've got a punch where I want to start a spot drill so that I can then drill these out. And then these are my perforated holes. I'm not sure how big they'll be. I've not done final decision. And again, here are the holes on each side. Again, this is, I'm going to call this the beta, the prototype. I've got 3 more pieces of steel that would allow me to do 3 more sets of this if I don't like how it turns out. And there is the line that I will be bending to create that 60-degree angle. So the idea for, you know, the edges here, I've got quite a bit to trim off, would be these 2 sides are true. So I'm probably going to put this into the vise and then mill this down to a point. Same thing here. This is flat, so I'll probably do this one first. And the idea being to use these end mills. And it looks like my smallest end mill is probably going to be that size. So the idea would be to drill a hole large enough. What is this? This is 1/4 inch. So I would drill this hole to be a 1/4 inch and then just go back and forth, back and forth. Same thing here, only I would just do it, you know, in the square. I don't care about the edges being round, and these are round. So again, hopefully that this will work. We'll see. And same thing for this. This would be 1/4 inch. This would be 1/4 inch, but it wouldn't be with an end mill. It'd be with a drill bit. But I would do a center drill. What did I call it before? Spot drill, center drill. Center drill all these holes, all these punches rather, so that I can come in with a drill bit. And again, I don't know how big that's going to be. And I don't know how large this looks to be more than a 1/4 inch. So let me go get a caliper and I'll be right back. All right, so here's the machining caliper. And this is 3 3/4, 3/4 inch rather. 1 1/2, 3/8, 3/16, 3/4. So this should be, hopefully, the right collet size. Which one is that? That is the second one. So we will put that back for now. Not that it really needs to go into the bag. All right, 3/4 inch collet, R8. Hopefully that will fit. There is no way that is 3/4 of an inch. This is 0.3. Yes, I am Dumas. 3/4 of an inch would have been 0.7. That's 3/4 of an inch. All right, I'm old and dumb. So we know, I wonder how many people caught that before I totally effed that up. All right, so we know it's not going to be this one. That's 1.5 inches. We probably don't need this bag anymore. What do we have here? That is not 5/8, because 5/8 is about that big. 3/8, I'm going to say hopefully it's close to 3/8. Yes. Bingo. All right, so the idea is to lock this in, and with these holes drilled, come down into the hole, start it up, and I don't know how successful I'm going to be. As opposed to with a larger end mill. What do we have here? 1/2 inch? Yeah, this is 1/2 inch. Do I even have 1/2 inch? 5/8, 1/2. I think this is 1/2, not 1.5. We'll see. Yeah, that looks to be a 1/2. Okay, so looks like I have the collets in order to, again, what I'll probably do is clamp this in and then clean this edge up. Actually I'll probably sand this one because this one's right on the edge. Same thing here, so I won't do anything with any of the tools, and then I will probably clean this up, this edge up here with coming in with the end mill. Same thing here. I'll just keep trimming this off. This is longer, this is wider than this line, so I'll probably start here and trim to this. Then I will use the bandsaw for this, and then I will use the mill to do that. Same thing on this side. I will come in with the wider side first, do that up to about here, then come in and do the more narrow side, slightly more narrow side, and that should be that. So that's the next time we talk will probably be when these are all drilled and milled. So stay tuned. More to come. More to come. Never a dull moment. And yeah, these are probably not going back in the bag. All right, that's it for tonight. Later. We have made chips. A little bit of a mess. Put the end mill in and kind of just carve that out. I also shaved this side off a little bit, so this is nearing final size, if not final size. I think I have a little bit more to shave off, but we've got chips. Hello folks, Reloading Bench back with you once again, and this is going to be 2 videos that tie into the same topic. So I'll make a segment for my update on my crafty little thing, which I was doing so well until that one. Yes, and this ties into the problem or the issue I was having, and my vise isn't big enough to clamp this, so I wasn't able to use the end mill to do this as eloquently as I had hoped. So this is actually a hack, and the last thing to do besides powder coat it is to bend it 60 degrees. This piece is identical and tapped to be identical to the tape being the top. Why it's this size and why there's this weird overhang is because of the original. So that's that. That's this update. So I'll see if in class, my last official day of class, I can do something with a tool that can help me make this bend eloquently. Otherwise, I'll be hacking it at home. All right, that's it for this update. End of video. Good evening, folks. We're going to bring this particular project, this version of the project, to an end. I took my aluminum and brought it to my last machining class to ask, did they have a machine that could do a bend, a 60-degree bend? And they're like, oh yeah, we got a machine. So I grabbed a piece of scrap aluminum they had and did a couple of test bends. That's a heavy-duty machine, and it did this with relative ease. You know, once you take precaution to lock everything in securely, and then, you know, it was a manual machine, not a hydraulic. So I did these two bends, and I'm like, all right, let's bring it on. And I did my my official bend, and as I was bending, I heard the crack. So it was doing just fine until it wasn't. So the bend I had was about, let's see, the bend I had was oh so close. So I had about that much of a bend, so I still had, you know, 10, 15 degrees to go. And when I pushed it that little extra, that's when I heard the snap. So when I talked to the instructor, he's like, well, what kind of aluminum was it? I'm like, well, it was Amazon aluminum. I don't know. I didn't pay attention. You know, 6160, whatever, 70.XX or 70XX. He said, you want high ductile, very pliable aluminum. So I'm going to take this back to square one. So we're going to call this a lot of practice, some success, some failure. The bottom plate is still good, that goes underneath here, but yeah, this didn't turn out so well. Don't know how I'm going to, what I'm going to do, I'm going to look for some different aluminum, maybe something a little thinner that I'll be able to bend at home in a vise with a crescent wrench. But yeah, this did not end as well as I had hoped. So that is that. Unfortunate.